To add or subtract polynomials, we collect like terms. Let's first review some definitions. A polynomial in one variable x is a sum of terms of the form a times x to the n, where a is a constant and n is a non-negative integer. Non-negative integer means that n is greater than or equal to 0. Because we don't know how large n is, we typically subscript our coefficients to match the corresponding power of x. Here are some examples of polynomials. It's important to note that collecting like terms uses the distributive law of multiplication over addition. Recall that two terms are called like terms if they have the same variables raised to the same exponents. Let's consider examples of collecting like terms. 2x and 3x are like terms and can be combined. The sum, 2x plus 3x, equals the quantity 2 plus 3 times x using the distributive law. Performing the addition inside the parentheses yields 5x. Similarly, 3x squared minus 7x squared equals the quantity 3 minus 7 times x squared, which equals negative 4x squared. 1/2 x plus 1/3 x can be computed similarly. We get the quantity 1/2 plus 1/3 times x using the distributive law. Now we need common denominators to add the fractions. Using a common denominator of 6, we get 3/6 plus 2/6 times x, which equals 5/6 times x. To add polynomials, we collect like terms. Problem instructions will be something like add and simplify. To add these polynomials, we might first use the associative and commutative laws of addition to rearrange the terms. We can write our degree 5 terms together, followed by the degree 3 terms, and our linear terms. Now it's relatively easy to collect like terms. We get 10x to the 5th minus 3x cubed minus 4x. Let's consider another example in which not all the terms pair up nicely. We can still write our terms in order of non-increasing degree. We have 2 cubic terms, 1 quadratic term, 1 linear term, and 2 constant terms. Now collecting like terms is easier. We get minus x cubed plus 3x squared plus 6x plus 1. Let's consider one final example with fractional coefficients. We will again reorder our terms in order of degree. We have 2x to the 4th terms, 1 cubic term, 2 quadratic terms, 2 linear terms, and 2 constant terms. It also appears that some of our coefficients will add to 0. So we get 1/3 x to the 4th plus 5/3 x cubed minus 4x. We usually omit writing the terms with coefficient 0, so we leave out 0x squareds and 0 for the constant. Recall that the definition of subtraction is addition of the opposite. A minus b equals a plus the opposite of b. The opposite of a polynomial is the polynomial with opposite coefficients. Remember that opposites add to 0, so we need all the terms to add out. Some examples are helpful. The opposite of x plus 2 is minus x minus 2. The opposite of minus 3x plus 7 is 3x minus 7. The opposite of negative 2x cubed plus 8x minus 5 is 2x cubed minus 8x plus 5. One way to think of finding the opposite of a polynomial is to distribute the negative. Now we're ready to subtract polynomials. To subtract polynomials, we distribute the minus sign and add. Instructions on these problems will be something like subtract and simplify. We have a subtraction problem, so we distribute the minus sign and rearrange the terms to make collection of like terms easy. We put our x to the 5th terms together, our x cubed terms together, and our linear terms together. We get 4x to the 5th plus 5x cubed minus 14x. Let's consider a second example. Again, we distribute the minus sign and reorder the terms conveniently. Combining like terms now produces minus 9x cubed minus 3x squared plus 6x minus 3. Let's look at an example with fractional coefficients. Again, we're going to use the definition of subtraction to distribute the minus sign and then add the coefficients. We're going to rearrange the terms in order of decreasing coefficients or non-increasing coefficients. So we have our x to the 4th terms, an 1x cubed term, x squared terms, linear terms, and our constant terms. Finally, we're going to collect like terms, and we get 1x to the 4th minus 5x cubed plus 6x squareds minus 10x plus 1.